Now we're going to talk about Bitcoin, which is abbreviated as BTC, how addresses and keys work. And I kind of hinted at this earlier, and it probably seemed confusing. It really needs its own video, and we'll talk about it here. So one of the things that is hard to wrap your head around in the beginning is what all these mean. So we're going to use PR for public key, for private key, excuse me, PR, so private. That turns into a public key, or PU, and then that turns into an address, or AD. What you usually see, let's say you're watching a YouTube video and you see an address, it says donate BTC, and then they give you their address, and it's this whole string of letters and numbers. So that's the address. Let's go back to our example of the locker in the train station. Okay. The address is the number of the locker. Okay. The private key is the password that you use to get in here. And the public key is sort of an intermediary. The private key is hashed to get the public key, and then the public key is hashed to get the address. And how it's hashed, how many times it's hashed, is not that important. What you need to know is that however many times you hash this number, you're always going to get the same result. And all three of these are just numbers. Private key is a number, public key is a number, address is a number. You may be thinking, well, I saw letters in there. It's not. So we talked about binary. We talked about base 10. So a binary number is like this. Base 10 number is like this. But there's also other bases. There's base 26. Base 26 just uses the lowercase ABC, uses the alphabet, and there's 26 numbers for each digit place. And it's a way of compressing numbers. There's hexadecimal, which is base 16, and he uses 0 through 9 and A through F. So A, B, C, D, E, F. So 6 additional digits on top of 0 through 9. Okay, so that gives you 16. Bitcoin addresses use 0 through 9 plus A through Z lowercase plus A through Z uppercase. And then they eliminate some letters that are confusing. So like uppercase 0 and uppercase O and 0, and then uppercase I and lowercase l, which in certain fonts look almost identical. So these are removed, and then you have all this, and that allows you to take a long number if it was in binary, or a long number in base 10, and a shorter because you have more basically digits to play with for each digit space. So now each digit space, instead of 1 or 0, you have 0 through 9 and A through Z and uppercase A through uppercase Z. So you have tons of options. You can write a big number in fewer digit spaces. So the address itself is shorter. All right, so what you need to imagine is a train station that has miles and miles of lockers. So you go all the way down a few miles later and you have locker number 1,500,101. Okay, so you take a private key like 5 and you hash it and you get some other number like 1,500, and then you hash it again and you get 1,500,101. So that should have been square. Okay, so I want you to see the parallel. And it was hashed here. So what you do is, the way Bitcoin does it is you generate a random number, which is a really big random number. It's a really long random number. And it's actually pretty difficult to create random numbers. You don't really need to know how it's done on computers, but just know that it's hard. And if you're not creating them correctly, it can really mess up the whole system. So you have a random number, you hash it to get a public key. Okay. And then you hash it again to get an address. And the key is, remember with hashing, you can't go backwards. You can't figure out what the input to the magic black box is that gives you that output postage stamp hash result. You have no idea what went into it to create that output. So you start with your private key, you hash it to get your public key, you hash it again to get your address, and now you know, okay, this number unlocks this locker, which contains this Bitcoin. And now you control this locker. And anybody else who goes up to this locker, they don't have this random number that unlocks the pad on this Bitcoin. Okay, so that's how Bitcoin addresses and keys work. You get the address by hashing this random number. And you may be thinking, well, so anybody could just be using any random address? It turns out because of the length of the address and the number of digits that are possible, everybody just starts with a random number. They hash it to get their address. And it's what we talked about in the hashing video with the word collision. It's extremely, extremely unlikely that two people are going to generate the same random number and therefore generate the same address. And so because of that, everybody will, just by using this system, start with a different private key and end up at a different address. And because there's no way to go backwards with hashing, you can give out your public address and nobody's going to be able to get back to your private key. Part of the reason why this intermediate public key exists is to make it even harder. So even if a computer could somehow get brute force from the address, they don't go from the address to the private key. They go back and they have the public key. And the public key does not unlock the locker. You'd have to go back again to get the public key. And that just makes it that many times harder. It's the equivalent of, instead of you have a safe and there's a padlock on it and you have to guess the combo to this lock, it's instead there's two safes and there's two combo padlocks. So you have to first guess the 3-digit number that unlocks this padlock, and then once you're inside, you have to unlock this one. So you have to try every single combination from 000 to 999. So like if you ever seen a briefcase that on the top, it has 3 tumblers that go from 0 to 9. That means you have to brute force 1,000 combinations to get the combination. So imagine there's another briefcase inside here where you also have to brute force it. Okay, so there's another 1,000 combinations required. So it makes it that much more difficult to get the secret message inside the briefcase within a briefcase. All right, so that's how basically the Bitcoin address and key system works.